This discussion is about empirical molecular formula as well as percent yield, all topics you did in Intro Chem. Remember, formulas can be empirical formulas or molecular formula. Empirical formula, like this one, CH, is the simplest whole number ratio between the elements within a compound. Molecular formula is actually a multiple of that. You multiply the subscripts by some integer that you then figure out. Molecular formula, for example, is C6H6. It's actually benzene. And benzene is CH, the empirical formula, multiplying through by 6 on all the subscripts. That's the actual formula for the compound. So if you were going to talk about benzene, it actually has 6 carbons and 6 hydrogens, but it has an empirical formula of CH. For the chemist, it's really more of a theoretical idea and a mathematical relationship. It's not the actual way the molecule goes together. So you should be familiar with questions like this one. This says the composition of this acid is 49.3% carbon, 6.9% hydrogen, and 43.8% oxygen by mass. Molar mass is 146 grams per mole. So the question is, what is the empirical formula? In other words, what are those subscripts? What are those lowest ratios? Sometimes an empirical formula can be a molecular formula, and we're going to find out in this case if it is. So remember, the subscripts are mole ratios. So the first thing you want to do is to convert the percent to moles. And we are assuming a 100 gram sample. Why do we care? Of course, well, in any sample, you're going to have 49.3% carbon and 6.9% hydrogen and 43.8% oxygen. But in a 100 gram sample, that would mean you actually have 49.3 grams of carbon, 6.9 grams of hydrogen, and 43.8 grams of oxygen. And that, of course, makes the converting to moles very easy. So when you look up the formula mass for carbon, hydrogen, and oxygen and divide appropriately, you should find that carbon, when I did it over here before I started recording, I got 1.5. For hydrogen, I got 2.5, and for oxygen, no, I did not get that. It's after I divided. Sorry. Backing up. For carbon, I got 4.1. For hydrogen, I got 6.9. I knew that was wrong because obviously hydrogen has a mass of 1, and when you divide that into 6.9, you get 6.9. Oxygen is 2.74. So I converted to moles, and I actually now write moles as subscripts. And there it is. To simplify, I now divide by the smaller number. And that's what I actually wrote down first, so I apologize. Obviously 2.74 is smallest. And now we get, 1.5, hydrogen as 2.5, and oxygen with no subscript because 2.74 divided by itself is 1. Now, instead of rounding 1.5 to 2 and 2.5 to 3, this is a special case, as are other ones that we will look at in class. But this is the most common one that we did in the intro class. And what we are going to do is we're going to multiply all of these through by 2 to preserve the ratio. When you do, there's the answer, C3H5O2. And that's the correct answer. The molecular formula might be the empirical formula. And so what is the molecular formula? Well, what you do is you take the mass of the molecular formula. So C3, so 3 carbons. Carbon has a mass of 12. So 12 times 3 is, of course, 36. Hydrogen with a 5 has a mass of 5. And oxygen with 2 is 32. And when you add those up, you get 73. Now, that is not 146. The molar mass that they give you, and you're going to divide it by the empirical mass. So you're going to take 146 and divide it by that 73 that we got when we added up 3 carbons, 5 hydrogens, and 2 oxygens. And of course we get the number 2. That means the molecular formula is 2 times as big as the empirical. And you can see the answer, C6H10O4, is the molecular formula for this particular acid. And that's how we do empirical formula and molecular formula. A very common, straightforward, easy calculation that you should be familiar with. The last concept on this video is percent yield, an important indicator of the efficiency of a particular reaction. Obviously we'd like 100% yield, and there are lots of kinds of questions that involve percent yield. I think in intro we were just trying to figure out how close we were to the true value. What was our percent yield in the product? So, however, in industry you want to have 100% yield or close to that. So how do you calculate that? Pretty easy. The actual yield over the theoretical yield. The actual yield is actually what you get in a lab situation, and the theoretical yield is what you get when you are calculating mathematically, and multiply that by 100, and that is percent yield. Oftentimes questions will not ask for percent yield because it's too easy. They will use this question in relationship to something else, and you will see this in the next video about stoichiometry. You'll see how percent yield is used, and again we'll do more practice in class. Thanks.